Alright, hello. Now I'm going to be talking about implicit differentiation. But before I talk about the actual steps to finding the derivative, you're probably all wondering what it means for a function to be implicit anyway. Well, there are two types of functions, implicit and explicit. Explicit functions are functions in which the dependent variable is written explicitly in terms of the independent variable. So y is explicitly in terms of x. So examples of these would be like y equals x squared plus 7, y equals x cubed plus 8, and the opposite of that is implicit functions. So instead of having something like 3x squared, you have 0 equals x cubed plus 7xy squared plus y cubed. Basically, your function in terms of both x and y. So when we're trying to find dy dx, or the derivative of something like this, there's a pretty complicated process. What you want to do first is find d over dx of both sides. So since you're differentiating with respect to x, it's a different process. So yeah, since the derivative of 0 is 0, we just leave it like that, and we differentiate term by term. It's like the sum rule for derivatives. So the derivative of 3x squared is x cubed is 3x squared. And next we have a product rule here, so I'm just going to put the constant out. So the first function, x, times the derivative of the second function, y squared, which is 2y dy dx. I have the dy dx here because, like I said earlier, we are differentiating in terms of x, and with respect to x. So that's why we have that there. And next, the derivative of x is 1, and then it's y squared, plus 3y squared, the derivative of y cubed, dy dx, for the same reason I mentioned earlier. So now, to simplify, next what you want to do is isolate the terms that have dy dx attached to them. So I'm going to put the other terms on the other side. So negative 3x squared equals 7x2y dy dx plus 7y squared plus 3y squared dy dx. And negative 3x squared minus 7y squared equals 7x2y dy dx plus 3y squared dy dx. And now what you want to do is factor out the dy dx. So now we have negative 3x squared minus 7y squared equals 14xy plus 3y squared times dy dx. Because, it's like algebra 1 factoring, you factor out the dy dx, and next you divide both sides by this term, so you're left with just dy dx. So dy dx equals negative 3x squared minus 7y squared over 14xy plus 3y squared. And that's a very, very, very ugly function. But don't worry, you don't have to simplify implicit functions. But you don't have to simplify these implicit functions. But you will probably on your AP exam or on your test be asked to evaluate implicit functions on a certain point, but that's pretty simple because you just plug in what the point is. Like, say, find dy dx at the point 1, 3. You plug in 1 for x and 3 for y. Just to do that for you at 1, 3, that would be negative 3x squared, so negative 3 times 1 squared, which is 1, negative 3, minus 7 times 3 squared, which is 9 times 7, 63, over 14xy, so that's 3 times 14, which is 42, plus 3y squared, which is 3 times 9, 27, and that is negative 66 over 69. So yeah, that's pretty much the steps you take for implicit differentiation. Yes, I think that's all I have to say. If I realize I forgot something about this, I'll add a little bonus clip. But that's all I can think of right now for this step.